So let's talk about a general case projectile. And this is when an object is launched from the ground, goes up, and then comes back down. Okay, it makes a full parabolic shape. So there's some things that you have to keep in mind whenever you're talking about a general case projectile. Please make sure you understand that the horizontal direction properties are different than the vertical direction properties. In the horizontal direction, it's very similar to that of a horizontally launched projectile, where the velocity in the x direction is constant. Okay, the horizontal component of the velocity will always be the same. In this case, the acceleration in the x direction is still 0, because that's what constant velocity means. Okay, but in this case, you are launching it from the ground and going up. Okay, so keep that in mind. You're going to have to find your VXO by using some trig, and because you're going up from the ground, your triangle is here, so the horizontal component is the cosine of the angle. I like to call the launch velocity VO. Sometimes I'll refer to it as my VR, my resultant. That's the hypotenuse of the triangle. Okay, you're still going to have one equation in the x direction because your velocity is constant. So VXO times t. Please keep in mind when you're talking about the time here, this is the time of flight, and that is the whole path. Okay, in the horizontally launched projectile, it's only half of the time, technically, because it's only going from top down. In this case, the flight is the whole thing, up and down. Which brings me to a component of the vertical. Okay, a property of the vertical direction is that this is similar to a vertical launch. Okay, so all of the properties for a vertical launch in the y direction are going to apply to a general case projectile's vertical components. So your max height is where the object stops. Okay, that's what it means when Vy is 0. The velocity in the vertical direction at the maximum height is 0. The time to get to Ymax is half the total time. Okay, so a parabola, you know, is symmetrical. So everything on the left is going to be the same but opposite direction on the right. So if I were to launch something at 10 meters per second, it's going to land at 10 meters per second. Whatever the angle that I launch at is going to be the angle over here. They are symmetrical. All right. So let's try one of the problems. If I have an object that is launched from the ground at an angle of 32 degrees at a velocity of 15 meters per second, how far away does it land? Okay, so the first thing that we're going to do is write down some givens. What do I already know? So that way I can determine what I am missing. So some givens to me, theta, the angle which I launched at, and my launch velocity. If you don't like VO and you want to call it VR to remember that it's the hypotenuse, that's totally okay. Whatever is easiest for you. It's the same thing in my book. Okay, and it's asking for how far away does it land. So if I know it's looking for delta x, and I only have one equation that I can use for the horizontal direction, I need to find these variables. Okay, just like before, I'm going to find the time using the y direction. But I'm going to use equation 3 because I know my